Hello, in this video we are going to find the average power of the signal sin square omega n. The question is like this: if x of n is equal to sin square omega n, find whether the signal is an energy signal or a power signal. So I am going to give you a solution which is very easy and simple to follow. So when we see the question, we can identify that this signal is a discrete time signal which involves a sine function. There is a tip for all of you at this point. Whenever a sine and a cosine function appear as powers or products, then the actual frequency differs from the one given explicitly in any problem. So in such cases, we have to rewrite the given expressions in any form without powers or products for simplification purposes. This can be applied to all signals and systems problems whenever there is a power in your sine or cosine function. In this problem, since we have sin square omega n, which involves a power of 2, we can rewrite the given signal using trigonometric formulas and eliminate this power. So we will use this trigonometric function sin square theta is equal to 1 minus cos 2 theta by 2 to simplify our signal. So we can write our signal x of n as 1 minus cos 2 omega n by 2. Now, to check if a signal is an energy or a power signal, we have to follow the following steps. The first step is to compute the energy of the signal. If the energy is finite, then we classify it as an energy signal. If the energy is infinite, then we compute the power, and if this power is finite, then we classify the signal as a power signal. Now, if both energy and power are infinite, then the signal is classified as neither energy nor power signal. So let's first compute the energy of the signal. The formula for finding the energy of any given discrete time signal is given by E is equal to summation n is equal to minus infinity to infinity x of n whole square. So we'll substitute for x of n here, and when we can see that in order to square this, we will get the terms 1 plus cos square 2 omega n minus 2 cos 2 omega n, and the denominator is 4. So we can take out that as a common multiplying factor 1 by 4 outside the summation, and now we can see that there is this cos square 2 omega n term here again. So we can again simplify this through our trigonometric formula. Cos square theta is equal to 1 plus cos 2 theta by 2. On substituting it, we can see that we can further simplify it with a common denominator of 2, and you get 1 by 4 summation n is equal to minus infinity to plus infinity 3 plus cos 4 omega n minus 4 cos 2 omega n by 2. So this, note that there is this cos 4 omega n and cos 2 omega n terms here, and it is summed up from minus infinity to plus infinity. There is another tip here. To simplify such expressions, the average value of any sine or cosine is 0. So any summation or integration between minus infinity to infinity, whether it's a cosine or a sine, the value will be 0. So replacing this cos and this cos by zeros, we'll be left out with 1 by 8 summation n is equal to minus infinity to plus infinity 3. This becomes infinity because this summation sums up 3 infinite times. So total summation will be infinity. So since the value of E is infinite, the given signal is not an energy signal. Now that we know that it's not an energy signal, let us calculate the power of this signal. So the formula for finding the power of any discrete time signal is given by this expression. You can see it is average power, average over a particular length. The length we are taking is from minus n to plus n. So while averaging, we have 2n plus 1 points. That's why we have 1 by 2n plus 1. Now we can use the same simplified value of the summation which we saw for energy here for easily computing the power from the previous computation and write it directly as P is equal to limit n tending to infinity 1 by 2n plus 1, and this term, this summation was 1 by 8 summation of 3 from the last slide. So here if you see, the only difference in the summation is minus infinity to infinity is replaced now by minus n to plus n. And we can take this 3 outside the summation, so it becomes 3 by 8 summation minus n to plus n 1. We know that when the summation of 1 from minus n to plus n is 2n plus 1. There are, it's 1 plus 1 plus 1 plus, so many n ones are there from minus n to plus n. So it is 2n plus 1. Now we can replace this summation by 2n plus 1 in our power expression, and you can see that this 2n plus 1 and this 2n plus 1 cancels, and there is no limit n tends to infinity now because it's a constant. So the power is 3 by 8. So hence the given signal is a power signal. This is how we can calculate the energy and power of a signal and classify it as a energy or power. Thank you.